Is your heating system driving you crazy? Mine definitely is. I'm stuck with an ancient heating system that blasts heat to the whole house at once. That means small, well-insulated rooms turn into saunas. At the same time, bigger spaces or areas near doors or with big windows remain freezing cold. The thermostat doesn't help. It measures the temperature in the living room, leaving the rest of the house a mystery. My heater burns gas, and the heater pushes air through old-fashioned floor vents, just basic holes in the floor, with no way to control which rooms get heated. I mean, I could manually open and close the floor registers, but that's not exactly what I want to be doing every morning and evening in my bedroom. But here is my solution. I can't upgrade the heating because I don't own the house. So I am building a smart vent control system. I will be using a 3D printer, a Raspberry Pi Pico and a few inexpensive components. The whole project will cost just around $30, but it will save me from this hassle for years and help me lower my heating bill too. I designed this floor register in Fusion 360. I had to split it into two parts because it's bigger than my 3D printer can handle. I'm trying to print it now, but of course things never go smoothly. First, I'm getting some serious warping. Apparently there is something wrong with my printer settings. But that's not even the worst of it. I completely messed up the design. The two parts don't fit together at all. In a day, I redesigned the register, ensured both parts would lock together, and gave it a second try. The second print was even worse. I wanted to make it sturdy, so I chose a 50% print density. As you can see, that turned out to be a mistake. I'll reprint with a standard 15%. Finally, I've got something appropriate. Now I can print the rest of the register. It took me 3 attempts to print all the components, but now I'm ready to move on to the assembly process. Now let's talk about the connection schema. Here are all the components I need. A Raspberry Pi Pico, a DS18B20 temperature sensor, a stepper motor with a controller board and a resistor. All components are powered and controlled by the Pico. It's a straightforward setup. For the first test, I will assemble everything on a breadboard according to the schema. With the hardware ready, I can move on to the software, setting it up step by step. First, I'll clone the repository I prepared for the project. Then I'll run the command git submodule init and git submodule update. Now I have the required folders on my laptop. My focus is on the Pico Micro Python folder, which I'm opening in the Visual Studio Code. I'm using MicroPython to program the Pico. Visual Studio Code had the MicroPython extension, which make everything easier. The only change needed in the code is to update the Wi-Fi name and password, which I'll enter here. At the bottom of the file I have schedule that closes the dumper between 7 AM and 8 PM and opens it during the night. Now I'll connect the Pico and run the code. I'll upload the project and press the run button. The first two messages on the console are crucial. The first confirmed that the board recognizes the temperature sensor. The second confirmed that the Pico is connected to the local network. After that, the console shows additional messages. The final message is the most important. The Raspberry Pi broadcasts a message to the local network, signaling it's ready to communicate. That means everything is working as expected and we're ready to solder all the components and assemble the register. Since everyone has a mobile phone, I created an app to control the floor register. In my code, there is a folder called Mobile Kotlin Multiplatform. This folder contains the codes needed to run the application on any mobile device, whether it's an iPhone or Android. To make that happen, I just need to open the folder in Android Studio, wait for a synchronization, connect my Android phone with a USB cable, and press the run button. For iPhone it's a bit more complicated as it requires Xcode. Feel free to drop a message in the comments if you need help with that. Once the mobile application is running, I can power up the floor register and give it its first test. I didn't have to wait long to encounter my next failure. I completely underestimated the size of the micro USB connector which need to fit inside the case. Just when everything seemed perfect, I discard this. Of course, it wasn't the only flaw. Luckily, humanity invented tape. The cherry on top is organizing and attaching the wires to the wall skirting using custom 3D printed cable holders. From now on, I can control room heating through my phone, on a schedule, or based on the room's temperature. No more manual switching and no more overheated spaces. If you have any questions, feel free to ask in the comments below. I'll be more than happy to help. Cheers!